All right, 26. The domain of the square root of x squared minus 25. Now, one number that I know I am not allowed to plug in for x is the number 0, because if you plugged in 0, you would get a negative 25 under the square root, and that's bad. All right. It looks like I can plug in really big numbers for x. Like if you plug in 10, 10 squared would be 100, 100 minus 25, and then that would give you 75, and you can square root that. You are allowed to take the square root of a positive 75. And you can also plug in numbers like negative 10, because when you square negative 10, you're back to 100 as well. The way we did this in class was we kind of looked at the graph of x squared minus 25. And if you want to, you could graph it on your calculator. X squared minus 25. Zoom. Standard. Okay, it looks something like this. What it is it's shifted 25 units down, so negative 25, and it's opening upwards like this. All right, now what you want to find is you want to find these x-intercepts where the function is equal to 0. It turns out that happens at 5 and negative 5. Okay, if I hit trace 5 for x, yeah, you see it happens right here. Now the idea is that we're taking the square root of this function, and you can only take the square root of positive values. Well, this function is positive as long as it's above the x-axis like this. So from negative 5 to positive 5, we cannot take the square root. All right, that's why 0 is not in the domain. All right, but if we do any number after 5, all right, so from 5 to infinity, or if we do any number before negative 5, negative infinity up to negative 5, those would be acceptable values for our domain. Okay. So our domain is going to be, I'll do it both ways. X can be greater than or equal to 5. All right, X is allowed to equal 5 because you can take the square root of 0. All right, that's this part. So from 5 to infinity. Or X can be less than or equal to negative 5. All right, that's that half. So as long as the function is above the x-axis, right, it is part of the domain. The other way to write it would be negative infinity to 5 union 5 to infinity. Okay, that one matches that piece, and then that one matches that piece. Okay. Of course, you can make a number line out of it. I guess I can do that real fast. Okay, it'd be a closed dot at 5 going to the right. It'd be a closed dot at negative 5 going to the left. Now, number 27, this one's actually really easy. If you check out the graph, it's just the same graph right here, opening up, and it's going to be shifted 4 units up instead. Something like this. Now you see that it's always positive. This entire function is always above the x-axis, which means that the function, no matter what you plug in for x, because you're squaring the number and then adding 4, the value is always positive. So you're never at risk of taking the square root of a negative number. What that means is that the domain is going to be all real numbers, right? Or you could say it's negative infinity to positive infinity. Right? No matter what you plug in for x, you'll never run into any issues.